All right, Harry, here we go. So here's the problem. I'll let you read it.
Right.
So do you think you can do this one?
With the stoichiometry and all that stuff? I think so.
What's that?
Yeah, I think I could.
Okay, so what's the balanced equation?
Uh, you put a 2 in front of the silver nitrate, and you put a 2 in front of the silver chloride.
Good. You can see that I've left the states off because we're just worried about balancing it. Okay, so I'm going to move everything up a little bit. What mass can be produced? Tell me the road map, if you will, the pathway.
Well, you'd first start with 0.156 of barium chloride, and then you need to
Whoops.
go to
Go ahead. I'm sorry.
you need to go to moles of barium chloride,
And then?
and then you need to go to moles of silver nitrate. And then end with grams of silver nitrate.
Great.
Okay, one sec. Let me grab my book.
So let's figure out what some of these masses are. Barium chloride is 137 plus 0.33 plus 35.45 plus 35.45. So if I remember right, that's around 2 something. 208, I think.
Okay, sorry about that.
No worries. So this guy has a molar mass of 208.23. Silver is 107.87. Nitrogen is 14.01. And 3 oxygens is 48. So this has a molar mass of 169.88. So how would you write down the actual calculation?
Well, you would start with 0.156 grams of barium chloride.
Excellent.
And
you're writing this down as we go, right?
Yep.
Good.
And then you would multiply it by 1 mole of barium chloride on top. And then you would have the molar mass of 208.23 grams on the bottom of barium chloride.
Okay.
And then you would multiply that by, you'd have, what is the balance? You have 2 moles of silver nitrate on top. And then you have 1 mole of silver nitrate on the bottom. I think is how it is. No, sorry, 1 mole of barium chloride on the bottom.
Right.
That's my bad. And then you would multiply, the last one would be the molar mass of silver nitrate on top over 1 mole of silver nitrate on the bottom.
Okay, and our answer, why don't you estimate the answer for me?
All right. Well, shoot. I was poor at this when you did it the other day.
Well, try and keep it simple. What numbers seem the best to work with? Wouldn't you agree that 2 and 208 have something in common?
Yeah.
I mean, basically, this is 2 divided by 200, isn't it?
Right. It's 100.
So that's 100 on the bottom, right?
Right.
How many times does 100 go into 169.88?
1 point, would it be
1.7, right?
1.6, 1.7, yeah.
And what's 1.7 times 0.15?
It, about 0.255.
Okay. So I think we did this one yesterday, didn't we?
Yeah, I think so, yeah.
Well, let's find out what the answer is then. How many significant figures are we allowed?
3.
Okay. And 0.255.
Yep.
So were you guessing or were you remembering the answer from yesterday?
I was guessing. I did the 1.7 times 1.5, but
Okay.
I didn't remember what the answer was from the other day.
So what mass of silver chloride is produced?
0.255 grams. Oh, wait, that's a different question. Sorry. Oh shoot. Well, then you have to we'd have to. You couldn't do the molar mass stuff because you don't know what that is for barium nitrate. That wouldn't work. Oh shoot, I don't remember how to set this one up.
Really? Can't you
Yeah.
just do it the same way you did this one?
Oh,
Only
but
here, instead of silver nitrate?
that's what you do with silver. Yeah, you could. Yes, that is exactly what you could do.
That's exactly what you do. So without putting out the pathway,
It would
it
be
would be,
You'd start with 0.16 grams of barium chloride, wouldn't you? Oh, we have to figure out the molar mass of sodium chloride.
right, and that's going to be 107.87 plus 35.45. So 143.32. So what's this number going to be?
Oh, move it down a little bit. I can't.
Oh, I'm sorry.
That's fine. Well, you could do 2 back into to 200 again for 100, and then if we're estimating it
Or Harry, couldn't we just use this number and say it's got to be
around there,
less than 0.255, but more than 0.2, say?
yeah, that works too.
It does, doesn't it? In fact, you could also look at this compared to this. This is 170. This is 143. 34 is 20% of 170, right?
Right.
And 34 minus 170 is 136, so that's pretty close to that. So you could say that the answer is going to be this minus 20%,
Oh,
right?
right.
So 0.2.
Yeah.
Let's see what we get. .2147. So 0.215 grams of aluminum chloride. What do you think?
Yeah.
Okay. So there's that problem. Let's do another one. I don't think we did this one.
No. We did not.
So ethane burns in oxygen. What are the products? And you can see that it says write a balanced reaction. So we can do A and B at the same time, can't we?
Yeah.
So C2H6, what does it react with?
Is it reacting with oxygen?
Right, when it says it burns in oxygen, that means you need oxygen for it to burn. That's why when you have a stove fire, if you put a lid on the pot, it burns itself out because all the oxygen gets used up.
Oh.
That's also why a lot of extinguishers are made out of CO2.
Oh.
CO2 is a gas, so when you spray it over the fire, there's no oxygen for the fire to react with, so it stops being a fire.
Oh.
And that's why if you give CPR and you still do that mouth-to-mouth resuscitation, you don't want to hold your breath, because if you hold your breath, you build up the CO2, and when you breathe into the person's mouth, there's no O2.
Oh.
Now, hopefully you'll never be in a situation where you have to give mouth-to-mouth. Besides,
No.
I think they don't want you to do that anymore.
No.
So what's the formula for oxygen?
Just O2?
That's right. What are the products?
Oh, jeez.
What does all of the carbon turn into?
What's it doesn't does it turn to CO2?
That's right. What does all of the hydrogen turn into?
That just stays hydrogen?
Nope.
Oh, would it become hydroxide?
Nope.
Oh.
Have you ever cooked, Harry?
Yeah.
What kind of stove do you have, electric or gas?
Electric.
Electric, okay. So then you won't be able to help me out there. Have you ever burned a candle?
Yes.
Okay, and have you ever done that experiment where you hold a glass over the wick?
No, I don't think I have.
Okay, so I can help you out there. So I'll tell you what happens. It turns into H2O.
Oh.
So if you have a candle and you light it and you hold a glass over the wick, you'll see water condense on the glass.
Oh. Okay.
And it's from the combustion of the wax.
Oh.
Okay, so let's balance it.
Well, there's 2 carbon on one side, so you have to put 2 in front of that. And then there's 6 hydrogens, so you should put 3 in front of the H2O, but then that would make 4, 7. Oh, that's a weird number.
Not a
But then
weird
you'd be
number,
left
it's an
with-
odd number.
Yeah, then you'd be left with 3.
Weird and odd are different.
You'd be left with 7 oxygen, but there's 2 oxygen on the other side.
How about this? What's 7/2 times 2?
14 halves?
What's 14/2 if you simplify it?
7?
Okay, so here we have 2 carbons, 6 hydrogens, and 7 oxygens, right?
Right.
What do we have over here?
2 carbons. 7 oxygen, and 2 hydrogen.
Okay, but I'm going to make the list the same as
Oh, wait,
over
6
here.
hydrogen. Sorry, 6 hydrogen.
I'm going to make the list. You did oxygen first because you ran into it first.
Oh, right,
I want to make the list the same as this list so I can compare them like this.
right.
If I make the list like this, I might compare these and think they're different. You see that?
Yeah.
So you make the list the same way on each side if you're going to make a list. So it's balanced. Do we like fractions as coefficients?
No.
What do we do?
Don't you double everything?
Well, let's find out. That's your hypothesis that if you double everything, it'll be okay, right?
That one, yeah.
Well, there's your hypothesis. How do we test it?
By seeing if it's balanced.
Precisely. How many carbons?
4 carbon,
Hydrogens?
12 hydrogen,
Oxygens?
14. It's not balanced.
How many carbons?
4 carbons,
How many hydrogens?
12 hydrogens,
How many oxygens in CO2?
8,
How many in H2O?
6,
And 8 and 6 are?
14. Oh,
So your hypothesis was you're going to double all the coefficients and it should still be balanced, only we'll have whole numbers, right?
right.
And we tested your hypothesis and your hypothesis came out to be true. So that's a good idea to double everything. Fair enough?
Yep.
Okay, C. What mass of O2 in grams is required for the complete combustion of 13.6 grams of ethane? So we're going to need the molar mass of oxygen, which is 32.00 grams. CO2 is 44.01 grams. Hydrogen, or H2O, is 18.02 grams. This guy here is going to be 12.01 times 2 for the 2 carbons, plus 6 times 1.008 for 30.07 grams. Okay, that being the case, if we're going to start with 13.6 grams of ethane, and that, of course, is this formula here, they want grams of oxygen.
Right, so would you do times that by 1 mole of ethane on the top and then the molar mass on the bottom?
What would be next?
And then it would be, we're doing O2, right? Should be 7 moles of O2 on top. And then 1 mole of ethane on the bottom. No, 2 moles of ethane on the bottom.
Yeah. Now, you got caught, didn't you, almost?
Yeah.
So maybe when you're balancing this, you do this. And that way you don't look at that anymore.
Right. And then would be next would be, you have 1 mole of, no wait. No, you'd have 1 mole of O2 on the bottom and then molar mass of O2 on top.
And I actually like starting with mole of O2 first because that's what you want to cancel. And then you put the other part on top. Would you try to estimate this one for me?
You could. 2 could go, 2, you could have the 2 moles of ethane go into the 32 grams easily for, what is it, 16? And then this 7 almost goes into 30, 4 times, and then with 2 left over, and then the 13 is just, you have to finagle that in somehow. 16, 32, and then what?
So let me show
Usually
you what
about 4-ish.
Let me show you what I do. I look for things on top and the bottom that are really, really close. And if they are, it's 1. What's 32 divided by 30?
Oh, be about 1, wouldn't it?
About 1. Okay, good. So that's great. Now I just have 13.6 times 7 divided by 2. How many times does 2 go into 13.6?
Almost 6 times with about 1 left
6,
over.
almost 7 times, right?
Almost, yeah. Almost 6 times 7.
So 7. What's 7 times 7?
49.
49. Okay, so let's try it. Now, over or under, if you had to guess?
What,
Over 49 or under 49?
I have to guess probably under 49.
Okay.
Maybe?
It's kind of a toss-up because here we're making the number too big when we say 14, right?
Right.
But here, this divided by this, we said it was
It's
1,
1.
and it's really more than 1, right?
Right.
So here, when we did this, we made it too small. When we did this, we made it too big. So it's really a toss-up. And I get 50.7. What do you get?
Let's see. Yep, I got 50.7 as well.
Okay, excellent. So D is, what is the total mass of products expected from the combustion of 13.6 grams? So I'm going to rewrite the equation. We know that we reacted 13.6 grams of ethane, and we know that we need 50.7 grams here. Their question is, how many grams of products?
Right.
They don't ask for how many grams of CO2. They don't ask for how many grams of H2O. They ask for how many grams of product. What do you think?
Well, if you wanted to do a lot of work, you can always find the mass of the CO2 and the H2O and then add them together, but
Yeah, you could add the mass of the CO2 and H2O together. What does the law of the conservation of matter say?
what is it? Is it in a chemical reaction, I think it's the mass of the matter can't be created or destroyed.
Okay, so that means that if you start off with 5 grams, what do you end up with?
You end with 5 grams?
Okay, what if you start off with 64.3 grams?
You'd end with 64.3 grams?
I think so, don't you?
Yeah. Oh, so you could add those two up, and is that what the total mass would end up being?
That's right.
Okay.
Now, interestingly enough, a couple days ago, you caught on to this. But a couple days ago, we had this number, we had this number, and we had this number, and you only had to get the mass of the remaining part. And so you did a little subtraction. This one kind of tricked you because it didn't ask for the mass of either one of these. It just asked for the total mass.
Oh.
What is the total mass? Okay, now, if you had done it your way and done all the work for CO2 and done all the work for H2O, would you have found the same answer?
Yeah.
Yep,
Should've.
absolutely. But you also would have spent way too much time on the problem and not finished the test.
Yes.
You don't want that to happen.
No.
Okay, let's try another one here. This is a limiting reactant problem, and the following are pretty much going to be limiting reactant type problems, okay?
All right.
This is one of those gas forming reactions. This is actually a base. A base plus ammonium salt gives you ammonia.
Oh.
So, do you understand the concept of limiting reactants? Let me describe it to you. Have you ever made peanut butter and jelly sandwiches?
Yes.
Okay. Have you ever taken a whole loaf of bread, a fresh jar of jelly, a fresh jar of peanut butter, and tried to make sandwiches?
Yes. I think so.
Okay, what do you run out of first, the bread, the jelly, or the peanut butter?
Would you? I guess depending on how much you use, would you run out of the? Oh gosh. Oh, you run out of the. I don't know. I haven't made a ton of peanut butter jelly sandwiches.
You haven't? What, someone cooks for you, Harry?
Well, I haven't had a PB&J in years.
Why not? They're wonderful.
They are. We just don't have
Okay,
them.
so let me change it a bit, okay?
Yeah.
Let me change it a bit. Let's say you're building a bicycle. We've talked about this one before, right? If you're building a bicycle and you have 2 bike frames and you have 10 wheels, so this isn't 10, it's supposed to be 10. 2 bike frames and 10 wheels, how many bikes are you going to be able to build?
2 bikes.
2 bikes because you use up the frames, and how many wheels do you use up?
Only 4 wheels.
Only 4, and you have 6 left over.
Oh, so is it the frame the limiting?
So in this case, we would say the frames are the limiting reactant and the wheels are in excess. Okay, so let's see how we figure out which one is limiting and which one is in excess. 2 ways of figuring out limiting reactant. Here's one way. So I'm going to draw my little bicycle frame here. And there's my 2 wheels. And when we put them together, we get 2 bicycles. Oh, excuse me, 1 bicycle. My bad. So do you understand the picture here?
Yeah.
So imagine we have 2 frames and we have excess wheels. We're going to make 2 bikes, right?
Right.
And if we have excess frames and 10 wheels, we'll make 5 bikes.
Right.
Now, if we have 2 and 10, we're going to make 2 because it's the lower of the 2. We run out of frames first, right?
Right.
So one way to do it is to take, let's call this A, let's call this B, and let's call this C. Take A and figure out how much C you can get. Take B, figure out how much C you can get. And whichever C is smaller, the reactant is limiting. And which C is larger, the reactant is what?
Excess. Could be excess.
That's right. Now there's another way to do that. Here's another way to do that. So we're going to look at this situation where we have 2 and 10. What you could do is you could take A and figure out how many B you need. So let's see what that looks like. We have 2 frames times 2 wheels per 1 frame, which is 4 wheels, right?
Right.
Okay, so this is what we need. We have 10 wheels, so there's going to be leftover wheels. And if there's leftover wheels, then what's limiting?
Frames.
Frames. And that's what we figured out here too, right? The frames are limiting.
Right.
Another way we could do it, which is number 2 also, is instead of starting with A, we could start with B and figure out how much A we need. So we have 10 wheels times 2 frames per, or 1 frame, excuse me, per 2 wheels, and you get 5 frames. That's needed. We have 2 frames. So what does that mean about the frames if we need 5 but we only have 2?
Still the limiting.
It's limiting. So up here, we found out the wheels were in excess.
Right.
And the frame is limiting, right?
Right.
Down here, we found the frames are limiting and the wheels are in excess. Do we come to the same conclusion regardless of whether we start with A or B?
Yeah.
Yeah. We come to the same conclusion, but maybe in a different order for what is in excess and what is limiting. Are you with me?
Yep.
Okay, so that's how we go about doing this. So let's apply both methods to here and see if we come to the same conclusion. So let's try that first method where we figure out how much we're going to make. Now, when we figure out how much we're going to make, do we want to figure out how much ammonia we're going to make, H2O we're going to make, or calcium chloride we're going to make?
We're going off the question that we have, or just
That's what I would do.
So it wants to know the ammonium.
Right. So I would base it on how much ammonium we make. Does that make sense?
Yeah.
So ammonium has a molar mass of 17.03. Calcium oxide has a molar mass of 40.08 plus 16. So this is 56.08. And ammonium chloride is 14.01 plus 4 times 1.008 plus 35.45. So this is 53.49 grams. Okay, so we're going to start with 112 grams of calcium oxide and multiply by what?
224 grams of ammonium chloride on top?
No.
No. Oh, wait.
Here's a hint.
Oh, so you put the molar mass of it on the bottom. I was thinking.
Now what?
And then would you do the oh, and then you'd have one more. You'd have one mole of calcium oxide on the bottom, and then you would do 1 mole of ammonium on the bottom, and then the molar mass on top. Jeez.
Okay, how about estimating this one for me? Do you see any two numbers here that just call out and say, use me?
56 and 2. Or 112 and 2?
112 divided by 56.
Oh, it's
2 times 56.
2. So,
Okay, so 56 will go in there 2 times.
right,
What's 2 times 2?
4?
Okay, I don't like that. What's 2 times 17?
I cannot do something like 34.
Okay, what's 34 times 2?
68?
So our answer is 68. Are you with me?
Ish, yes.
Ish, 68-ish. And the reason I didn't want to do 2 times 2, because then I have 4 times 17, and I don't like that. Okay, what do you get?
I got 68.022.
0.0, right?
Yep.
And remember, you estimated 68, right?
Mm-hmm. Yeah.
Pretty good. Now let's try 224 grams of ammonium chloride.
Well, it would be, you multiply it by 1 mole of ammonium chloride on top. And then the molar mass on the bottom. And then you would do 2 mole, no wait, how many? Yeah, 2 moles of ammonium on top over 1 mole of ammonium chloride.
Really? I think it's 2.
Oh no, it is, sorry, yes, 2 moles. I was
You were
thinking the wrong
dividing
thing.
2 by 2 and getting 1, right?
Yeah, I was thinking of something else.
Don't do that. Just use the number
Yeah.
and worry about that stuff later. Just use the number from the balanced reaction.
And then you, excuse me, and then you do the molar mass. No, wait. I'm losing myself somehow. Yes, and then you get what you get.
And then you get what
I
you get.
keep getting confused with the numbers.
Okay, now do this. How many times does 53 go into here?
About 4.
About 4 times. Okay. What's 4 times 17? We already know it's 68, don't we?
68.
Now, how many times does this go into here really? Is it 4 times exactly?
No.
A little bit more than 4?
Yeah.
So a little bit more than 4 times 17 is going to be a little bit more than 68. So we expect this answer to be a little bit more than 68.
Right.
All right?
All right.
What do you get?
We got 71.1. Is that what you got?
I don't know what I got. I'm waiting for you to do it.
I got 71.1, but I might have done. I think I did the math wrong.
222 times 17.03 divided by 53.49, right?
Oh, so I got 70.7.
Okay, so if this is the case, what is the mass of NH3 that we're going to make? Is it 60.8 or 70.7?
Oh.
68.0 or 70.7?
Don't you add them?
No.
Oh.
Remember, with the bicycles,
Oh,
We could
right,
make 2 and 5, right?
right.
Did we add them and say we can make 7?
No, we didn't.
So what did we do? If you can make 2 or 5 bikes, how many are you going to really make?
You're gonna make. Wait. Oh, 2 bikes. You're gonna make 2 bikes.
Right here, we said if you can make 2 or 5, when you combine the 2 together, you're going to make the
2
smaller
bikes.
amount because you run out of frames,
Oh,
right?
so then you would make. So you should have 68 grams then.
So here, you should be able to make 68 grams. So you don't sum them. Okay, what's the limiting reactant?
Would that be calcium monoxide?
Right, and what is the excess?
Ammonium chloride.
Ammonium chloride. Okay, so that's one way to do it. Here's another way to do it. What we're going to do is we're going to start with 112 grams of calcium oxide, and we're going to figure out the grams of ammonium chloride needed. Okay?
All right.
So what do we do here?
Times it by the molar mass on the bottom and 1 mole on top.
Good. What next?
And then
And here, I guess I better show you this. The balanced reaction.
then you have 1 mole of calcium oxide on the bottom and 2 moles of ammonium chloride on top.
And
then you'd have 1 mole of ammonium chloride on the bottom and the molar mass on top.
let's see how many grams we need. Can you estimate this answer?
Well, yeah, you do the we could do the 56 into 112 again for 2, and then could you do the? Then would you multiply the 53.49 by 2?
And what do we get?
Well, 53 times 2 is 106, but and there's the other 2 left over.
So 212 grams.
Ish, yeah.
Ish. So let's find out what we get.
Is that at 56.08? I got 213 point, I guess 65, which I guess be 214.
214, thank you. I'm going to take your word for it.
So
okay, so here's where we have to do a little mental thinking. We need 214 grams of ammonium chloride. We have 222 grams of ammonium chloride. So what does that mean? Are we going to use up all the ammonium chloride, or will we have leftovers?
We're going to have leftovers.
That's right. So leftover ammonium chloride, which means it's what?
It's a
excess, right?
An excess, yeah.
Therefore, calcium oxide is limiting. Correct?
Yeah.
Okay, so here we said ammonium chloride was in excess. Here we said ammonium chloride was in excess. We came to the same conclusion either way. But you got to understand here, we're not done. We would still need to calculate the amount of ammonia you make. So how would we calculate the ammonia that we make? Do we start with the excess or the limiting?
We would start with the. Would you start with the limiting?
That's right. Because the limiting is going to determine how much you make. Now, we've seen this before because we did it above, but we're pretending that we did not do it above. You with me?
Yeah.
So if this looks familiar, it's because we've seen it before. And we get 68.0 grams. So we could either do it this way, where we start off with both and find out how much of the product we make. And when we do this, we're doing 2 long problems, but we get the excess, we get the limiting, and we get how much you make. Are you with me?
Yeah.
If we do it this way below, we still do 2 long problems. We get the excess, we get the limiting, and we get the amount of product we make. So either way is fine, and either way takes about the same amount of work. This way, though, takes a little more thinking. Because imagine if this said we needed 222 and we have 214. So reverse these. We need 222 and have 214. What would that mean? That would mean this would be limiting.
Limiting.
Okay, if you need more than you have, if you have less than you need, that's limiting.
Oh.
You know, like if you're making food, like say spaghetti, and you have like 2 gallons of spaghetti sauce, but you have 2 noodles, how much spaghetti are you gonna make? 2 noodles, right? The less, you know, for a gallon of spaghetti sauce, you need about 10 packages of noodles.
Yeah.
Not 2, 10 packages, maybe 20, depending on how much sauce you like. Okay, so I kind of like this way better. And I like this way a little bit better because, well, they both start off as similarly. I should say this one, you'll notice, ends the same.
Right.
And you just pick the lower number, that's how much you make.
Right.
But here, you have to avoid the trap of adding these together.
Yeah.
Here, you don't have to avoid any trap of adding them together, but you do have to go through this mental exercise here of figuring out, okay, so what do these numbers mean as far as excess and limiting goes? And then you have to remember that you start with the limiting to calculate how much you're going to make. Okay?
Right.
You'll notice above, though, we still started with the limiting to find out how much you're going to make.
Oh, yeah.
Okay, so there's that problem. Let's take a look at another one here.
All right.
So for A, how do you want to do it?
Well, you do it similar if you did the last one.
It's your choice. Do you want to figure out, if you read the rest of the problems, do you see that?
Yeah.
So how do you want to do this? Do you want to do it where you figure out the mass of aluminum chloride that you make from this, the mass you make from this, or do you want to figure out how much you need of one based on the other?
Let's do the one where you get the mass of the aluminum part from the at the
Of
end.
the product?
Yeah.
Okay, this is 26.98. This is 70.90. And this is 133.33. So those are the molar masses of the three things. So you can't see that. There you go. So what do you want to start with first?
What else? We said the aluminum. So 2.70 grams of aluminum.
So let's estimate the answer.
Well, 20. Oh wait.
How many times does this go into that?
13 times.
15?
15, 13.
No, how many times does this go into that?
Does 2 go into 26? Or 2 go into...
Does 2.7 go into 27?
Oh! No, well, not evenly.
Isn't this basically 27? I'm going to flip it. 27 divided by 2.7. What do you get? 27 divided by 2.7.
You get 10.
10. So we get 10 on the bottom, right?
Right.
How many times does 10 go into 133? 133 divided by 10.
13 times.
13 times. So we're going to say the answer, we're going to guess 13.3-ish, right?
Right.
Let's see what we get.
I got 13.3.
That's a pretty good ish, right? Okay, now let's try 4.05 grams of chlorine. This one will be a little harder to estimate, but we can do it. How many times does 70 go into that?
Well, we would only go into it once with a lot left over. But
Yeah, it'll almost go into it twice. It's really close, right?
yeah.
This needs to be 140 or 142 for it to be twice. So it's really close. So let's say twice. What's 2 times 2?
4.
Times 4.
16.
Divided by 3.
About a little bit less than 6.
What? 16 divided by 3 is 6?
Wait, no, I said less than 6. So it'd be a little bit more than 5.
Okay, a little bit more than 5. But here's something to think about. This doesn't go into this 2 times, does it?
Sorry, say it again?
This does not go into this 2 times. It's less than 2, right?
Yes.
So that means that if 3 goes into 16 5 times plus a little more, and we know that number's too big because this is not 2, then why don't we just say 5?
All right.
You with me?
Yeah, I'm with you.
Our estimate's too large, so when we get to 5.3, we say, well, we'll just round it down to 5. So 5-ish. Let's see what we get.
I got 5.08.
And that's what I get. You get a similar number.
Yes, that's exactly what I got as well.
Okay, so now what does all this data tell us? Which one, how much do we make?
5.08 grams.
And that's called a theoretical yield. Another term that you need to know, this is how much of the product you expect to make based on the limiting reactant. What's limiting?
Would be the aluminum? No.
Chlorine.
Oh, chlorine, sorry.
Because it gives you the least. Which one's in excess?
The aluminum is excess.
Okay, so kind of got a handle on that?
Yeah.
Okay. B, what mass of aluminum chloride can be produced? .08 grams, right?
Right.
We already answered that. C, what mass of the excess reactant remains when the reaction is complete? So how much leftover aluminum?
Could you just subtract the 2?
We could do that, right? We are going to use 4.05 grams of aluminum, right?
Right.
We're going to get 5.08 grams of aluminum chloride.
Right.
How much aluminum did we use?
Oh.
1.03 grams, right?
Right.
So how much is left over? Does that look right?
Yeah.
There you go. Or you could do this. So here I'm calculating the grams of aluminum used. And I get 1.03 grams used, which is what we figured out by difference. Are you with me there?
Yeah.
So there's your answer for the leftover. Okay. Let's do a really simple one. This one is percent yield, and it's very easy. And it's based on a problem we just did.
Oh.
Not the one we just did, but previous to that. Do you remember the problem with calcium oxide and ammonium chloride?
Yeah.
And we figured that it was 68 grams for the theoretical yield, not 70 point whatever grams.
Yeah.
Okay, so we did this problem just a moment ago, right here. Okay, so it's kind of nice because this says the answer is 68, and we got that.
Yep.
Now, if only 16.3 grams of ammonia is actually obtained, what is the percent yield? So percent yield is equal to the actual yield over the theoretical yield times 100%, where the actual is based on the experiment and the theoretical is based on the limiting reactant. Okay? So you need to know all of those terms. In this case, they say is actually obtained, so that's the actual yield. The theoretical yield is 68 based on the limiting reactant, and then times 100%. So how about estimating this one for me?
It almost goes 16 almost goes into 68 4 times. It'd be more than
Okay, so 1/4 is what? As a decimal.
right. Oh, as a decimal, 0.25.
What's 0.25 times 100?
25%.
25% yield. How many significant figures are we allowed?
Ooh.
What was that?
Is it 2?
No.
Oh, it's 3.
Let me ask you, why do you think it was 2?
Because of the, I think of the 0 at the end of 68.
Oh, zeros count if you have a decimal there.
Oh, I forgot about that.
Trailing zeros
That's
count
why.
if you see the decimal. They don't count if you don't see the decimal.
Oh, okay. That's what got me mixed up. I just forgot about that.
So that's a do, don't. You do see the decimal, they do count. You don't see the decimal, they don't count. So what's the answer?
24%.
Close.
Or 23. 24.0%.
Right? Because you want to keep the 9, but you look to the right and that's a 7, so you round that up to 10. When you round that up to 10, you keep the 0, carry the 1, and the 3 becomes a 4.
Right.
If you want 3 significant figures, you have to keep that 0. And this means 24 grams obtained out of 100 grams possible, which is a horrible percent yield. Normally in chemistry, we like reactions where you get like a 90% yield. They're more cost effective. Okay. That's good. We'll call it a day there. How's that sound?
Yeah. Sounds good.
Okay. We'll catch you Friday. Oh, I don't know if you've noticed, but I posted 2 discussions in your next lab.
Okay.
The lab actually has 2 assignments, a pre-lab assignment and a lab assignment.
All right.
You want to make sure that after you read the lab notebook part, that you do the pre-lab before you actually do the procedure.
Oh,
When
yeah.
you read the lab notebook part and it outlines the procedure, the first thing it says is make sure you do the pre-lab before you do the procedure. So that's part of the instructions. Do the pre-lab before you do the procedure. Okay?
All right. Will do.
All right. I'll post another one probably on Thursday, tomorrow.
Okay. Okay.
All right. See you, Harry. Thanks for
Bye.
coming.
Yep. I'll see you on Friday.
All righty then.
Bye.